Okay, could be quickly go to the DLab 7. That is the way will be applied for the rest of the digital lab. Okay. In order to build the circuitry, okay, you can arrange C, U1, U2, U3, U4, U5, U6, whatever. However, make sure you have to connect power and you connect to the route. Then now, you're looking into the handout, okay? Okay, you can see they say test number 1 and the PCOP U1, U2, U3. That will be telling you U1, U2, U3. You only connect the wire for U1, U2, U3. Okay? And you get your test program, you can get the test 1 or test 2, and you can run it to test it. If it fails, that means easy for you to fix the problem. The thing is only 3 IC, U1, U2, U3. You're missing the wire or whatever. That's easy to correct that. You have to do until test number 1, test number 2 pass. Then you start with the next one. Okay? Now, you can see in the test program, okay, when I say U2 enable, what that mean to you? U2 enable. How much you understand when you're reading U2 enable?
Has to be low.
No. Okay. I'm telling you. U2 541, just a buffer. That means whatever you get the input, they will be go to the output. Okay? With U2 pin 1 and 19 must be 0. If they're not 0, the input output cannot connect it. So that's why in the program I say U2 enable. Then you must be understand. You must be do in order U2 pin 1 pin 19 to be 0. In order to get that, you have to write to port B pin 1 pin 2. That means pin 4 will be 0. That's what for U2 enable.
A and B got to be 0, right?
Right.
If pin 2 and 3 is 0, then pin 4 will be 0, and then that's on U3. Then on pin 2, 1 and 19 will be 0.
Right. That means we have to understand how this 139 working. 0, 0, the first low, 0, 1, the second low. 1, 0, next one, and 1, 1, next one. Low. That means the output low only one at a time. And that's why I say if you enable. Okay. Now, if you're looking on that U6 here, U6 still the same buffer. Okay. Input you will go to output with U6 pin 1 must be 0. So that's why we're using enable U6. Then you have to set U3 pin 5. U3 pin 5. Okay. You see right here. To be 0. That means you have to apply PB1, PB2 have to be 0, 1. So that one will be 0. Okay. So now, after you're done, for that one, that two, you start at that 3. They test loading. U4. Okay. If you're looking into here, U4 here. Okay. And if you're looking into PCOP, they say U3, U4, U6. That will be telling you the wire connected relate to U4, anything here. Okay? And also connect Y from U4 to U6. And they will be go to port C of the system. And now you can see I can get enable U6. That means pin 1 have to be 0. Okay? Then you can run the test. 3, okay, 4 load different. So if they working for first one, they will be working for next one. And the next one still loaded before. Still loading. So if you, after you connect the wire for the test number 3, then they will supposed to be passed up to number 8. Okay, then test number 9. Okay, the test for loading U5. You can see U5 here, 191. And now you can connect any wire regarding to U5. Okay, whatever here. And that is also U6. Okay, and you can see PCOP will be U3, U5, U6. That means all the wire have to regarding into U3, U5, U6. Okay, and next one will be loading different data. Now, you want counting up. I'm using the function if for counting up and if for counting up. Okay. If for counting, if5 counting down. And last one, test 7 segment. Okay. So if for counting up, okay, you already connected everything. Okay. You run the test program ready. Supposed to be part. And if5 same thing. Okay. And the last one will be get the testing for U7 and segment here. Okay. That's a manual program. Okay. And that program already for you. Okay, so basically some student already done for test number 8. Okay, anyone get any question?
Yeah, I have a question on U4 and U6. Is that when you would connect U8?
U4, U6,
There, the negative clock?
here, right?
Yes.
The thing is, we already using the positive clock here.
Right.
We don't have a positive clock for that guy. So that's why we have to add an inverter.
Yeah. When do we add that? I see. For second test or
No, when you testing for U4, then you have to connect that
okay. Okay. I just wanted to make sure.
related to U4.
Right. Okay.
Connect that, connect the wire here, connect the wire here.
Right. Okay.
Okay?
Yes.
Then you can run the test.
Yes. Yeah, it makes sense to me. I just it wasn't mentioned, so I wanted to,
Yeah, just one by one.
yeah.
So when you try to test U4, we don't care what connect here, right?
Right.
We not connect any wire here.
Right.
So if it's not part easy for you to take them out, how to find what's wrong. Okay? Otherwise, you get too many wire here. We don't want that.
Hey, Mr. Pham, I got a quick question.
Yeah, go ahead.
On U8A, pin 1,
Connect to negative clock.
yeah, but on pin 1, is that a 1? And then it comes, since it's an inverter, it comes out as 0?
That means negative clock, that means high to low, right?
Okay, high to low.
So
And
they
then-
go to
Then when
output.
it gets to U4, it's got a bubble, which is active low.
No, that's the wrong of U4. That's not bubble.
No, pin 2 U4.
Yeah, U4 have to be 0 to 1. Clock. You see U4, they get a bubble, right?
Right.
That schematic, they get a problem. They have to be high, low to high, not high to low.
High to, it got to be high to low, you said?
If you see on the schematic, the clock have to be high to low. But what I'm saying is the schematic get a problem.
Oh, the schematic is wrong?
Wrong, right.
So in other words, where the clock is at, there should not be a bubble there.
Exactly.
Okay.
Good observation there.
Mr. Pham, I have a question, just out of curiosity.
Go ahead.
On the same U8A, what if you eliminate U8A and just connect it to positive clock? Would that work?
Okay, now you can say you get a clock already here. Positive clock here.
Yes, sir.
If you want one more positive clock, that's why I using negative clock, using inverter to make it to be positive. Okay. Also, make sure, okay, this data cannot be changed. So if you connect it to P clock, maybe work, but I'm not sure. Okay, the thing is P clock connect to this guy and also connect to this guy. That's why I'm using negative clock and adding inverter.
Oh, so it's something like it delays the clock on U4. Is that it?
Different clock. The clock we're using N clock, not P clock. P clock we already using here.
But when pin 1 goes through the inverter, it goes from negative clock to positive clock.
Right.
Mm-hmm.
And then that bubble on U4 pin 2 should not be there.
Right.
Okay, got it.
But I cannot change it.
You try to trick us, right, Mr.
Just
Pham?
curious, Mr. Pham.
Yeah, go ahead. The thing is, what I want to do, I try to help you out to find out what happened. It's not working. That's what we call troubleshooting. For U4, you connect all of the wire relate to U4 and U6. Then you can test. They cannot wrong with the U1. Okay? But they can be wrong with U3. The thing is you're using U3 right here. Okay? So that is more easier to correct the problem. I've given you the example. The first thing they tried to loading number 9. They failed. And now you can measure, okay? A, pin B, pin C, pin D. Supposed to be number 9. 1, 0, 0, 1. Okay? And the second thing, load pin number 9 must be 0. If they not 0, you go back to U3 pin 10. U3 pin 10 here.
Mm-hmm.
They have to be 0. If they not 0, then you understand me. 0, 0, the first 0. 0, 1, next 1. 1, 0. That will be pin 10. However, make sure PD pin 1 must be low. That's what happened in my software for you. Okay? So if you get the data 1001 here, and you cannot get out here, you see U6 pin 1 must be low. So data can go. Okay? That is how to troubleshooting.
Mhm.
We're working by small circuit, not in general the big one. After you're done, then now you can see the big picture for the lab. If I say I short it, connect U3, U4, pin 1, no, pin 3, to route. Okay? So if I connect U24 pin 3 to route, what I want to do, that means I simulated some dog for the circuitry. So when you will begin to run the test, they will be failed. So what you think is wrong? The first test we test for data number 9, 1, 0, 0, and 1. That means the output here. However, I'm connected to route. So the come out A here, pin 14 cannot be 1.
Right.
A will be 0. So that failed. If you're looking into the display, okay, they say that will be expected. That means 1. Okay, measure will be 1, 0, 0, 0. Measure. So what you think you can do?
Well, you would follow it back, wouldn't you? Test U1 U1 pin 3?
No, you
No?
you can fail from that U1, U2, U3, right?
Right.
The thing is pin 3, you socket to route. Okay?
Uh-huh.
So that's why they fail at that one. So now, okay, I will be short U4 pin 14. Sorry. So expected number 9. And your measure will be 0 here. So you know wrong right here. Okay?
Mm-hmm.
What can we do?
Or you could go either way. You could test a pin 3, U4 pin 3. See what's coming into the IC, right? Or you could test
Okay.
what's happening over in U6 IC.
Now, okay, I tell you.
Pin
Very,
2. No?
very
Huh?
slow. When they stop, okay, display, we want and we get what I can do. Okay.
Mm,
I using the meter to take you for pin 3, right?
mm,
Okay, you get a 1. That means correct. Then what you need to do, I have to say, U4 pin 1 must be high, right? It's 0, they clear. So they must be high. U4 pin 9 must be low. Okay. And also you can get pin 10, pin 7 supposed to be high.
mm-hmm.
Okay. So look like you get everything input correct. And the output is not correct. What I just telling to you, the purpose is I telling you U4 not working.
Mm-hmm.
The thing is they get a correct input,
Right.
not output.
Right.
That is how to troubleshooting. And you do the same thing. When you start that U4, you're looking into what you want, what you measure, and you easy to correct the problem. That's what we're talking about, troubleshooting.
Yep. So how often do IC units, I mean, you pick a new IC unit out of a box of new IC units. How often are they not good?
Okay. Okay, the question is, that means you get a problem with the IC itself.
Uh-huh.
Okay. Now, before you want to run simulation, that's what I wanted. Your test program must be passed. Okay? Must be passed. And now, when you try to test U4, you're loading that one. Okay? You suppose get number 9, but you cannot. You take input here. Look like everything correct, right?
Mm-hmm.
Then now they draw on pin number 4. What can we do? First thing, you have to remove wiring to U6 pin 2. Okay? To make sure they not caught by U6, you just remove the wire and measure pin 14. If they high, that means U6 got the problem.
Okay.
Okay?
Mm-hmm.
So U6 got a problem here. then you have to looking into U6 pin 2, how many wire? Only one wire. Okay. Then you can change the U6. Really, U6 inside got a problem. You learn the way one way. You know how to troubleshoot the circuitry. That will be more easy for you for any circuit. That's what a technician have to do in the company. You run the test, they fail. You have to fix. And normally the circuitry board in the company, when engineer we design the circuitry, we get all of the document, they call it TRD, test required document. You have to collect that. They're telling you everything on the circuit. How to test. Not only technician, even I'm engineer, I'm not design this circuitry. I still have to get what we call TRD. That required document. When they design circuitry, they have to write everything out. Okay.
Mhm.
So the next lab I'm working on right now, okay, about the memory. And try to get along, okay, with the lab. You see that? Everything we already given to you, information of the IC
Yeah.
139, okay? That will be decoder. You can see that to table. Enable. If they high, they don't care what input A, B. All of the output must be high. And the red enable low. If you get 0, 0, the first 0. You see that? 0, 1, second 0. Next one, next 0. And the last one. Only one output will be low. Okay? This is talking about serial to parallel. Basically, you get input, serial coming. Output come out will be parallel. Okay? That will be 541 buffer octal. Very simple. That is input, that is output, and then controlled by pin 1 and 19. If 1 equals 0, 19 equals 0, input can go to the output. You're looking in the truth table here. E1, E2 low. Okay? D high, output high. Okay? E high, E1 high. Another don't care. Output will be high input impedance. You understand the high input impedance? That means look like this IC not connect into the circuitry. Okay? So they cannot loading any current. Okay? So either one pin 1 or 19 at the logic high, output will be high impedance. U1, E1, E2 low, input low, output low. That's a very simple. Okay? So, if you get any question, when I be there, I can help you out. But you have to learn from the way I try to fix the problem. Okay, any question, anything? If it's not, so I will stop here.
Have a great weekend.
Okay, so hope you guys get a very good time during this park holiday. Okay, and
Thank you, the same.
yeah, we'll see you on Tuesday.
Okay. Looking
Thank
Thank
forward.
you.
Make sure guarantee you on ready for the program. Okay.
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 Thank you.
Thank you so much.
Thank
Bye-bye.
you.
Good night.
Good night.
Merry Christmas, Happy New Year's.
Good night.